Hello, it's your friendly neighbourhood maths teacher here to give you a quick maths lesson on volume and surface area. So before we've talked about area and perimeter. Perimeter is the distance around the outside of a 2D shape. Area is the amount of space it covers. Volume is how much a 3D shape occupies in terms of space, in terms of air, in terms of liquid, okay? How much can you fit into a box? How much can you fit into a room, okay? So with area, we said the area of this shape would be what? How would we calculate it? Length times width. Very good if you remembered. Okay, so for this example, 5 centimeters times 8 centimeters, 40 centimeters squared would be the area. For volume of a 3D shape, this is a cuboid. Okay, I have three measurements. I have a height, I have a width, I have a depth, or a length, a width, and a depth, whatever you want to call them. There's three dimensions. The volume is found by timesing all three of those together, or we can think about it like this. It's the area of this main face times the depth, because this 3D shape is like a main 2D shape that's been dragged backwards. Okay, so it's the area of the main face times the depth. What would the area of this be? 3 times 4, and then we times that by 5. 3 times 4 times 5 gives me 60 centimeters cubed. Volume is measured in centimeters cubed because we're timesing 3 lots of centimeters together. Let's have a look at another shape. This is a triangular prism. Okay, what that means is it's a triangle that's been dragged backwards. Think of a Toblerone box. I always do. Okay, now I'm hungry. Again, what we want to do, the area of the main face times the depth. So what's the area of this main face? How do we do area of a triangle? Base times height divided by 2. Remember to divide it by 2. So if we do 4 times 6 divided by 2 times 3, that will give us 36 centimeters cubed. So if we do 4 times 6 divided by 2 to get the area of that face, times it by the depth, which is 3, do all that maths, we're going to get 36 centimeters cubed, again, with a 3. Okay? Let's look at a cuboid now. This is like a circle that's been dragged down. So again, the volume is going to be the area of the main face times the depth. Okay? How do we find the area of a circle? What do we remember? Area equals pi r squared. Apple pies are 2, remember? Area is pi times the radius squared. So if area is pi times the radius squared, it's going to be pi times 5 squared. What's 5 squared? 25, okay? So we'll call that 25 pi. I'm going to keep it in terms of pi to make the maths a little bit easier. Then we times that area, 25 pi, by the depth, which is 7. 7 times 25 pi, we do that maths, we work it out as 175 pi centimeters cubed, okay? This is how you find the volume of 3 different shapes. Go back and look at these individually if you want to recap, if you missed any of the details. Next, I want to talk about surface area. So if volume is the amount of space something takes up, the surface area is just if you covered all the surfaces, how much paint you would need, how much wrapping paper you would need. It's the area of all of the outside surfaces added together. Okay, so to find this, we're just going to find the area of every side of a shape and add them all together. So this front face here, 3 times 4 is going to give us 12 centimeters squared. The back is exactly the same because opposites are the same in a cuboid. 3 times 4 here, that's also 12. This left side here, 3 by 5. This is 5 here, okay, because that's 5. This is 5. That's 15. This one's the same, also 15. What about the top of the box? 4 along, 5 back. 4 times 5, 20, and the bottom is going to be the same. We add all of those together, we get 94 centimeters squared. It's still an area, so it's still centimeters squared. That's the surface area of the whole shape. That's how much paint you would need to cover it with. That's how much paper you would need to wrap it with. Let's look at another shape. This is our triangular prism again. I'm just going to add the areas of all the faces together. Okay, this front face here is a triangle. Half the base times the height. So 3 times 4 would be 12, half it would be 6. So this front face is 6 here, the back one is going to be the same, 6 centimeters squared. What about this left face here? 3 tall, 6 back. 3 times 6 would give us 18, very good. Okay, what about this bottom face here? 4 by 6 is going to give us what? 24, very good. Okay, and this sloped edge coming down here, 5 centimeters by 6 centimeters gives us 30 centimeters. Add them all together, we get 84 centimeters squared. Last one, surface area of a cuboid. This one is a little bit trickier because we need to know this area on the top, this area on the bottom, and the wrap around the side, okay? If you were to take this wrap around the side and flatten it out, it would just be a rectangle. If you think about running wrapping paper around a tube, when you pull it out, it's just a rectangle. It's just got 4 flat edges, okay? Let's start with what we remember about circles. So how do we find circumference and area? Circumference is pi times diameter, area is pi r squared. There they are. Cherry pie is delicious, apple pies are too. Okay, so area of this top face up here, pi times the radius squared. I'm still going to do it in terms of pi. The radius is 5. 5 squared, 25, times pi, 25 pi. Okay, so this top face, 25 pi centimeters squared. The bottom face is going to be the same, 25 pi. How are we going to find the wrap around the outside? We know its height is 7, but what is the distance it has to go around the outside? It has to go around the outside of a circle. The circumference is what we need to know. Okay, circumference is pi times diameter. In other words, the circumference of this circle is pi times the diameter. What would the diameter here be? If the radius is 5, the diameter all the way across would be 10. Pi times 10, so the circumference around this edge here, 10 pi centimeters. Okay, now we know the circumference and the height, we can just times them together, which would give us 70 pi centimeters squared. Again, we add them all together, that is the overall surface area of this cuboid. Okay, have a look back through this video. I've given you lots of different shapes, lots of different examples. Pause on each one, make sure you understand it, have a go at the questions with these different shapes that are in the description down below, and let me know if you have any questions.